Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss gamma ray emission, conservation of energy and momentum, pair production. Let's begin. What is gamma ray emission? We see radioactive elements radiates alpha and beta radiations. During that radiations, a parent nuclei formed its daughter nuclei by emitting such type of radiations, either alpha decay or beta decay. During that decay process, the daughter nuclei formed, first it is in that of excited state, and after that it will come to the ground state. During that phase, excited state to ground state of that of daughter nuclei, it will radiate radiations, which is nothing but gamma ray. So the gamma decay is the spontaneous emission of electromagnetic photon from that of nucleus. The emission of alpha or beta particles from the natural radioactive substance may leave the daughter nucleus in one or more excited states. When the nucleus in that of excited state and passes to lower energy state or ground state from higher energy state, it emits a high energy photon, and this photon emitted by a nucleus in an excited state is known as gamma ray. How we can say a nucleus is excited state or ground state? Come to that of nuclear cell model. If we consider that with the nucleus, in that of nucleus there are various cells as far as their energy level is constant. In that of cells, accordingly the nucleons are there. These are the nucleons, either proton or neutron, and each cell has corresponds to its own energy. As far as the electronic configuration in an atom is concerned, there are energy levels. If the electron come from its lower energy level to higher energy level by accepting extra energy, and higher to lower one by releasing that extra energy. Same applicable for that of nucleons. Inside that of nucleus, as the nuclear cell model we prefer. In that of scenario, when the nucleus in the excited state and come to that of lower energy level state or ground state, it emitted photon. That photon which is emitted is nothing but gamma ray. In gamma ray, there is no change of mass number or atomic number of the nucleus, because the gamma ray is produced at the expense of nuclear excitation energy. Therefore, from parent nuclei to daughter nuclei, due to the process of either alpha decay or beta decay, and the daughter nuclei in that of excited state, when that daughter nuclei excited state to ground state, they release gamma rays, but that daughter nuclei not change with mass number and atomic number. because that gamma ray is produced at the presence of nuclear excitation energy, not the contribution of such decay process. We can easily understood it by taking radioactive decay. Let us consider beta minus decay. X atomic number Z, mass number A, that is the parent nuclei. And that parent nuclei come to under that of beta minus decay process. So, we have the daughter nuclei Y. In that of beta minus decay process, that atomic number increased by 1 unit and mass number is same. 1 electron with antineutrino. This is the daughter nuclei. This is electron, that is antineutrino. And that daughter nuclei is in that of excited state. Therefore, here we used the star sign. Star represents the excited state. Excited state. In that type of decay process, now that daughter nucleus in that of excited state, it come to the ground state by releasing gamma ray. This is the daughter nuclei Z plus 1 A, which is in that of excited state. It come to the ground state Z plus 1 A by releasing gamma ray. This is excited state. That is the ground state. This is the gamma ray radiated. Now, we can understood it by taking the energy level diagram. If you draw the energy level diagram, this is the energy of X a nuclei. On that of beta decay process, during beta decay, that energy level we see, that is the energy of the daughter nuclei A Z plus 1 A in that of excited state. Again it come to the energy of its ground state by releasing gamma ray. This one the excited state, that one is the ground state. By releasing the energy of gamma ray, it come to that ground state. So, the energy associated with that of gamma ray is nothing but the energy difference in between these two energy levels. On that basis, the conservation of energy holds good. Let us come to conservation of energy and momentum. Conservation of energy and momentum. Let us prefer if during gamma emission the transition takes place from the excited nuclear energy state let E2 to a lower energy state E1, the transition from E2 to E1, the energy level of that excited state E2 and energy level of that of ground state let E1, then so the difference in their energy E2 minus E1 is equal to h nu, whereas h with the Planck's constant, nu with the frequency of such gamma ray photon, whereas h Planck's constant and nu, that is the frequency of gamma ray photon. Hence, energy remains conserved during gamma emission. In that of case, energy is conserved. Next, we have to show how momentum is conserved. The linear momentum of a photon linear momentum of a photon is, how to calculate linear momentum, that is energy divided by speed of light. For that of photon, energy of each photon, that is h nu divided by c, that is the linear momentum of photon. Hence, the gamma ray emission must make the daughter nucleus recoil with same momentum. In opposite direction. If the parent nucleus is at rest, is at rest. This is the parent nucleus. Now it is excited, daughter nucleus. We obtain gamma ray. So the photon momentum of that of photon s nu by c. In order to conserve that linear momentum, the daughter nuclei recoil with same momentum with opposite direction of that of parent nucleus. Let us choose capital M, that is the mass of daughter nucleus, capital V, the velocity of daughter nucleus, therefore for conservation of linear momentum, in order to conserve that linear momentum, here initial momentum is equal to final momentum. Since we consider that parent nucleus is at rest, so it is 0, and the linear momentum of that of photon s nu by c plus linear momentum of daughter nucleus, mass into velocity, h nu by c plus mv is equal to 0. This is the condition for that of conservation of linear momentum. At the same time, conservation of energy, that equation is valid. Conservation of energy. Next, another concept, pair production. Pair production during that of gamma emission. The transition of excited nucleus to the ground state can occur by the creation of electron-positron pair. If the transition energy, that be the important one, if the transition energy E1 minus E2 is greater than 1.02 mega electron volt, then we see electron-positron pair, and that type of phenomenon is called internal pair creation. Look here, this is the transition from excited state to ground state. If the energy difference, this is the energy difference, Planck's constant to nu, that is the frequency of that of gamma ray photon. If the energy difference is greater than of that value 1.02 mega electron volt, then we can say there will be the creation of electron and positron pair. That type of production we call internal pair creation. So in the process of pair production, a high energy photon is converted into an electron-positron pair. The process of pair production, a high energy photon is converted into an electron-positron pair, and thus it is a process in which electromagnetic energy is converted into rest mass energy. Photon gamma ray, that is the photon of energy which is in the form of electromagnetic energy and is converted to the electron positron pair. Electron have specific mass, positron also specific mass which is equal to the mass of electron. Therefore, that mass we called rest mass energy. Now the electromagnetic energy which is gamma ray, photon converted to that of electron positron pair which has rest mass energy. That is the nucleus. This is the atom. In that of atom, this will be the nucleus. Nucleus. Here is the nuclear field. Nuclear field. And when gamma photon is incident, one electron another positron which is called the pair production, electron positron pair. Electron positron mass same and charge opposite. The mass of positron is same as that of mass of electron. Here, with the help of this visual lecture, we understand the concept of gamma ray emission, conservation of energy and momentum in case of gamma ray emission, and pair production from that of gamma ray. First, gamma ray emission. Then, conservation of energy and momentum in that of gamma ray emission, that is the conservation of energy, here the conservation of momentum, and finally pair production from gamma ray. This is the condition. If satisfied, then electron positron pair is produced from that of gamma ray photon. So, with this useful and informative notes, let me wind up the session. Thank you.